Hi, this is DC here. Welcome to this one more video on PN532 Reader Writer. In this video, I'm going to show you how to use SRI4X and SRI512 RFID tag. So as you all know, the PN532 is a very reasonably priced RFID reader writer, and this is the best for the students project as well. And you're going to learn all the commands that are sent between the PN532 and the SRI cards. So I have covered these two tags extensively in my other videos where I discussed about how to use these tags using the SRI122 reader writer. So I would advise you to see those videos, and the screens or the software, the look and feel are the same in both SRI122 and PN532. So these are some of the things that you keep in mind. It is very difficult to find the SRI4K tags. I have few with me, since my last project, and even if you find them, buying one or two pieces, will be expensive as well. You can find SRI512 tags with a quite reasonable price, and again, the price depends on where you live. I live in UK, and I can't find many sites selling these tags. So as I mentioned before, in order to understand any tag, you have to have a copy of the datasheet. So you can find the datasheet of SRI4K and SRI512 from the manufacturer side. And if you look into my other videos on SRIX tags, I've also shown you some of the other places where you can download these tags. If you go to YouTube and visit my channel, and if you go to the playlist called Understanding RFID NFC tags using SRI122U, I've made a video called Using SRIX4K tag using SRI122. This was made almost a year ago. And if you look at my recent videos, you can see that I have made 4 videos on SRI512. And again, these are based on how to use these tags with SRI122U. And you'll also find videos on SRX4K using OmniKey 5421, and that's also one of the good reader writer. So in this video, I'll try to cover some of the important things about these tags, and I'm also making sure that I'm not going to repeat a lot from these previous videos. So what you see here is the PN532 board. This is a blue board, and I'm using the USB to TTL cable and connected to my PC. So I'm not using any microcontroller like Arduino or ST microcontrollers in between, because all the commands are sent from this software to this PN532. And if you already have this software, and this feature is available in version 1.5, and you'll also get the updates automatically when you start your software next time. And for my viewers who don't have the software, so you still don't have to worry. You're going to learn, get knowledge from this video as well. So the first thing you do here is connect to PN532, and I can see now at the bottom of the screen, I can see the version of the PN532 shown. Because of the size of this video, I'm afraid you can't see that. Now here you have to choose the SRI4K 512. Now I'm going to place a very old SRIX 4K tag. This is the tag I've used almost a year ago, and these tags were expensive when I bought. Okay, now if you click activate, So if you are from the development background, there's so many things you can learn from these commands. Now I have initialized PN532 by first sending a samconfig command, then the rfconfig is maximum retries, and these two are something you have to do before using any other commands. And this is a very popular command in PN532, that enlist passive tags. I'm setting these parameters. Again, I don't want to spend time explain the parameters because I already done these type of videos long ago in this PN532 series of videos. Now here, so PN532, even though this tag is a type B tags, so the way it is activated is something not according to the standard type B. So as soon as you place the tag is already ready for it to get into the activation loop. So the first thing we do is, when you hit this button, I'm telling the PN532 to load all its registers for type B type of tag, so that all the CRCs and all the frames. So the outcome of this tag is 0. It is PN532 says there are no tags of type B. However, so we don't want it to recognize a tag. We just want PN532 to configure internally and be ready for the type B frames. Now the initiate command is what you have to first start with. Now again, I would advise you to see those videos, please. And I'm just going to cover everything in brief here. So you have to do initiate. The initiate will return us the chip ID. So I got 83. Then you have to select it. Now once you send this select command, so the tag is ready for the communication. The next I'm sending the get UID, and the information here tells you about everything about what type of tag is it. It tells me whether it's a SRI4K or SRI512 or any other different types of tags. Now with that you can hit this retag. Because SRS4K has got around 128 blocks, this would certainly take a bit of more time than a smaller tags. Now, as I mentioned before, this is a very old used tag, and just to go through the structure of SRIX4K. So this SRIX4K has got 5 OTP blocks. So here is referred to as a blocks, followed by 2 counters, followed by so many user data, and followed by the last block called the system block. The block numbers are numbered from 0 to 127, and the last block, the system block, is always has a block number as 255. Now out of these user block, the top 8 blocks, the top 7 blocks or 8 blocks are lockable. You can see here from block number 7 to block number 15 are lockable, so you can lock them, and bear in mind the lock is just a permanent locking and you cannot undo it. So you can see here what I have done is, in order to read the block, I'm using the incommunicate through command of PN532. PN532, the firmware in PN532 does not support the SRX4K tags. So like the firmware of PN532 can read and write a MeFA tag or a Topaz tag, whereas it can't. It doesn't have a command for SRI4K. However, there is a command called the communicate through command, which can be used to send commands directly to the tag. Now if you see here, I'm using this communicate through, and these are the commands, and you have to look at the commands in the documentation. Now this is the documentation I referred to. I got 4 on K and 5 on 2 here. And this is the I want to mention this. This is the transition diagram of how the tags are different states of the tags. So this again, it's pretty straightforward. As I mentioned before, after the power is on, when the tag is brought into the magnetic field of this reader writer, it comes to ready state, and from the ready, if you send the initiate command, it comes inventory. From the inventory, if you send a select command, it comes selector state. So when in selector state, you can do all the read, write, and get to ID commands. And if you have done the work, if you can, when you send the completion command, it goes to deactivate command. Or if you are using the multiple tags, you can do a select a different tag, or when you select different tag, this tag goes to deselected, and you can select another tag. And all these different states, I've explained everything in detail in my other videos. Please take a look at those videos. So here, these commands are the read block command, and the commands, I think, starts from here. It's 0800, and to read block number 1, 0801. So likewise, I've been sending around 127 commands to read all the block. Eventually, to read the system block, and you have to send the block FF. So the system block has got the locking area where you can lock, and plus it also has got chip ID. You don't have to play with this chip IDs. Now when you send this get UID command, and the UID, which is 64-bit, when you decode that, you get this D0, which is always refers to type B. Next is the manufacturer code, which is STM. The 03, which is encoded here, tells this SRI4X, and this is the serial number. So I'm going to clear this, and let's do some normal the read and write. So I'm going to change. So let's play with the user data. So I'm going to change this as say 25. I can directly edit here 26, 27, 28. So I'm going to, if you look at here, there is a W for write and R for read. I'm going to hit the write command. Now it says the write to block 17 is okay. If you look at here, I have sent the write block command, and write block command is probably it's 09. 09 is the write block command, followed by the block number 17 hexadecimal number, followed by the 4 bytes. And here the bytes, it's 27, 28, 27, 26, 25. They are sent from the lower byte first. And in this type of tags, you don't get any write success response. The only way to make sure the write is success or not is to issue a read command, and you compare the data we have sent with the data you received. Now the software does the comparison and says the write is okay. So very simple. If you want to write in a very easy way, for example, I want to write a number which is 25,000. You can use this this section here. In fact, the version SRI122 never had this direct editing the grid feature. So that will be added soon there as well. Now here write. Now as soon as the write command, the same thing has happened again. Write to block 20 hex number, sorry, it's a decimal 20, and read. So that's how simple as and you can also write everything in bulk. Say I want to write from 16 to say 127, the last block. I want to write everything to 0. Now when you hit the write, now this would take some time because we are writing more than 100 pages, so 100 blocks. In fact, I had to pause the video for a while, so it took some time there. So you can see the message write to block 16 to 127 is okay. And if you look at what's happened here, I've been sending a series of write block and read block. So eventually, you know what? Only two types of commands, you have to know here. One is to read, one is to write. So there are no special commands. So even though you got a OTP here, the counters here, the system thing here, there are no special commands for writing this information. It's just a read and write. Now OTP, the OTP in this tag is something different from the OTP you come across with the MeFair or ultralight tags. The OTP here is resettable. I'm going to show you what exactly it means. So this tag already has got some OTP, and I'm going to set, or I'm going to use this OTP number 1. So you got enough number of OTPs here. You got 5 OTPs, and each OTP, the one-time programmable thing, has got 32 bits. So it's a very you can find this useful in a multi transport card or multi theme park or any other applications. I'm going to set the first 3 bits. The first 4 bits I'm going to write. So here write. So I've written. As soon as I write it, it shows the value F0, and you have to keep in mind these SRI4X tags, the default value of the memory is 1. Now when you buy a new tag, the entire tag is set to bit 1, unlike a MeFair where the default value of individual bits is 0. Now this is how you set the OTP, and in the OTP, once the OTP is set, you cannot reset it. So I'm trying to reset the first bit, and I'm going to write, and you get an error message. So because that's the way the OTP works. So when the OTP bit is set to 0, you cannot set that back to 1. Now the way you find that the mismatch is, so after you finish the write command, the read did not match, so it's an error message. It's an error, sorry. Now how do we, like that, I don't have to mention anything more about OTP because there are 5 OTPs here. You can play with that. So how do we reset this OTP? There is a way to do that, but before that, let's see the counters. This tag comes with 2 counters. The counter in block number 5, which is like any other normal counter, and here you have to decrement the counter. You cannot increase it. So I'm going to reduce this to 0, 0, and this is the hex number. If you say write, now the counter is returned. It's fine. This is just a normal counter. Now only thing here is you cannot increase the counter. You can only decrease it. Now in the counter in block number 6 has got 2 features there. One of the features is just a normal counter. The 20 to 21 bits is a normal counter. I can go here, I can change, I can decrement it. So it's fine. It's just a normal counter. Get to 70. Okay, the write is fine, but this one here, the 11 bits, is called as a reload counter. The documentation explains what exactly is this. So the default value is all ones. Now I already got this 125. Now in order to reset the OTPs, you have to first write any number less than the existing value. I'm going to write 124. If you look at this OTP section here, the message says auto array cycle is disabled. As soon as I write a number less than the current value, write, Now reload counter write to OK. And if you look at here, auto erase cycle is enabled, and this is going to enable until the tag is there. So if I go to my OTP again, I've got some shortcuts here. Click on a clear, and now if I hit a write, now the write will be successful. Now OTP is write OK. So we can remove these OTP values, but you can do only when the auto erase cycle is set. What exactly the auto erase cycle means? Now every time you click on a write command, whenever this state is enabled, the entire memory is first erased, then the new values are written. Otherwise, you cannot erase the existing value. You can only write a new value or change the value from 1 to 0, and you can't change the value from 0 to 1. That's how this erase cycle works. Now after that, we got one more feature here called the system area. System area documentation says it has got the log bits. Now in this particular tag, you can log, even though you got 127 blocks, you can log only from block 7 to block 15. I have already blocked so many blocks here. Just for demonstration purpose, I'm going to show you how to block. I'm going to block this block number. Sorry, I'm going to lock this block number 10. Now I'm going to put a tick here. Now all these graphical or all these controls or ticks and untick you do is eventually converted to a 32-bit number, and that's what is done before the write operation takes place. Now I'm going to say write. Now it's locked. You cannot write this any further, and also there's something else to keep in mind here. In some cards, I'm not very sure in SRI4X, the lock will be effective only after this tag is reset. I'm going to try to write to block number 10 now. So I can't. I'm going to take it probably here to user data. So write the block number 10. I'm going to write it to 0. Write. Okay, so the write is indeed possible. Now it is possible because the tag is still not reset. Probably this feature is already mentioned in the documentation. Now I'm going to try this again, but I'm going to do that after reset the tag. Just take the tag out and bring it back again. Now this time you don't have to go through activate. We are going to follow the transition or the state diagram in the documentation. So as soon as you place this tag here, it is in the ready state. I'm going to initiate. Every time the initiate is sent, you get a new random ID. I'm going to select it. Now the selection is done. I'm going to hit a read, and I'm going to pause for a while because it's going to take some time. I'm going to modify the block number 10. So I'm going to set this as write A, B, C, D, and write. And that the read after write did not match. So what we just came to know is, as soon as you lock the block, it is still writable. Okay, as long as it's on the reader writer. So once you take it out or once you reset it, the lock will be effective. So thanks for watching. That's all in this video. In the next video, I'm going to show you how to use the SRI512 tag. Thank you.